Hey y'all, Miss Brown here to read to you the Unit 1, Topic 1, Evaluate Continental Drift / Plate Tectonics 2021 quiz. So this is counting as a summative assessment, and I'm going to read the quiz to you. I'm not sure, y'all, if I have to enter answers in order to move, so if I just put like periods or dots, that's just so that I'm able to move through the quiz. So right here you enter your last name, then here you enter your first name, and right here you choose your class period or section. Okay, part 2, are you ready? Number 1, the hypothesis presented in 1914 that suggested that the continents have moved slowly over millions of years to their current position or location is called the theory of what? And this is a 4-point question. This chart right here shows you what the continents looked like before. So was that Pangea, plate tectonics, continental drift, or seafloor spreading? And what I'm going to do, y'all, is I'm just going to leave my cursor on the final answer choice for each one so I'm able to move on. Question 2, the portion of the upper mantle that is plastic-like layer on which the plates glide along is called the blank. So is this called the asthenosphere, the crust, the lithosphere, or the mantle? And I have this little picture of silly putty because that layer of the earth reminds me of kind of silly putty. Okay, number 3, the theory of continental drift was proposed in 1914 and was not widely accepted. Who was responsible for this theory? And this is a 3-point question. Is it John Dalton, Harry Hess, Edwin Hubble, or Alfred Wegener? Okay, number 4. The portion of the crust and upper mantle that is broke into large plates is called the what? And this is 3 points. They're talking about the crust and the upper mantle. And it kind of reminds me of this right here. So is that the asthenosphere, the lithosphere, the mantle, or the core? And remember, y'all, I'm just leaving my cursor on the last answer choice. I'm not saying that's the answer at all. I just have to put it there so I can move on to the next question. Number 5, which statement best describes convection currents? So use this diagram below to answer the following questions. And you see you have the trench, you have mid-ocean ridge, another trench, and then you have this hot air rising and cool air sinking within the mantle. So which statement best describes convection currents? Is it the cooler fluid air is less dense and rises, while the warmer, more dense air sinks? Is it the next one? The cold fluid air is more dense and rises, and the hot, less dense fluid sinks? Is it the third one? The cooler, more dense fluid sinks, and the warmer, less dense fluid also sinks? Or is it D? The cold fluid is more dense, so it sinks, and the warm, less dense fluid rises? Okay, number 6. About 80% of the Earth's volume is made up of this layer called the blank. So I have this diagram here to help you out. Pardon me, y'all. And I'm thinking about, they're talking about this layer right here, the 80%. Is that the crust? Is that the inner core? Is that the outer core? Or is that the mantle? And y'all, my thought for this is you're watching this video kind of side by side and you're watching me read the question and then you're taking a minute to answer. So make sure you're hitting pause and answering as I'm reading the question to you. Number 7, the Earth's inner core is what? Hot and solid, hot and liquid, cool and solid, or cool and liquid? The Earth's inner core, this inner part right here that I'm pointing at. Okay, number 8. Study the diagram below. Which of the following is the correct order from the oldest to the most recent? So that means from the oldest to the most current, like most present day. And it's going to show the shapes of the continents of Earth's land masses and how they've changed over time. So you're going to look at W, X, Y, and Z, and you're going to say which one is the oldest first and then the youngest last. So is it W, X, Y, Z? W, X, Y, Z. Is it ZXYW, ZXYW? Is it ZWYX? Is it ZWYX? Or is it XYWZ? XYWZ. Y'all, I feel like that was a test to how well I know my letters. Okay, number 9. The later theory in the 1960s that states that Earth's crust is broken into large plates that are moved by convection currents in the mantle is known as the theory of Pangea, theory of continental drift, theory of plate tectonics, or theory of seafloor spreading. So it's the later theory in the 1960s, and it explains pretty much why continental drift happened. Number 10, which of the following pieces of evidence suggests that many continents were once near Earth's equator? So this is Earth's equator, and they're saying that a lot of the continents used to be located near the Earth's equator. And why? Because of glacial deposits? Because of fossils and tropical plants? Because of volcanoes? Or because of mountains? And then you hit next. 1 sec, I need a quick drink break. Okay, y'all, moving on. Stand, wiggle, stretch it out. Get some oxygen moving into that brain. Do this little cat stretch, get you up and get you going. Okay, number 11. These circular currents in the mantle cause the movement of the plates. Are those contour currents, convection currents, crustal currents, or condition currents that cause that movement in the plates? If you look at my mouse, this kind of refresh, kind of circular movement is what I'm talking about. Okay, number 12, which of the following lists the correct order of the layers of the Earth from the center outward? So from the inside out. Is the mantle on the inside, followed by the inner core, outer core, and crust is on the outside? Is the inner core on the inside, followed by the mantle, outer core, and crust? Is the crust on the inside, followed by the mantle, outer core, and inner core? Or is the inner core on the inside, followed by the outer core, mantle, and crust? And don't forget, y'all, look at this picture up here to help you out. Okay, number 13, who was Alfred Wegener? Remember, it's pronounced Wegener because he was German. And wow, Freddie was super photogenic. Check out this GQ model here. So who is he? Is he the father of inventions? Did he theorize plate tectonics? Did he discover density? Or did he propose the theory of continental drift? Our man, Alfred Wegener. Okay, 14, which statement describes what Pangea was? What's Pangea? Is it a theory that Harry Hess proposed relating to convection currents? Is it a supercontinent containing all of Earth's land masses that existed 225 million years ago? Is it a dense sphere of solid iron found in the Earth's core? Or is it a super virus that spreads quickly and easily? And y'all, I'm noticing that's a typo there. My apologies. Okay, number 15. Approximately 50 million years ago, the Himalayan mountain range began forming in Asia. This formed a folded mountain that can most likely be explained by what? And that's the Himalayan mountains right there. How gorgeous. Okay, so is it formed by rapid deposition of huge amounts of sediments? And remember, deposition is when the particles drop and kind of layer. Were the Himalayan mountains caused by a collision of two crustal plates? Were the Himalayan mountains caused by low erosion of continental plate material? Or were they caused by the separation or the dividing of two crustal plates? Okay, number 16, this is a 4-point question, so a little more. Which set of evidence best supports continental drift? Notice how this says check all that apply. So you are going to check 1, 2, 3, 4, or all 5. So continental drift plates 225 million years ago. Notice how they kind of spread out, y'all. And don't forget, your test can also be a resource. So if you're seeing that this question's reminding you about another question from before, you can always go back and you can kind of check out those answers. So be using your test to help you out as well. So which evidence best explains continental drift? Check all that apply. Fossil evidence, Whiteness accounts to witnesses accounts to back up claim. Glacial evidence supports climate change. Continental fit, so it fits like a puzzle. And or landforms and rock layers match up. So notice how it let me check all of them. So you're going to check all that apply. Okay, next part, little brain break. Get some water, take a few deep breaths. So we will be completing the last part next. So here we go. Alfred Wegener's 1915 book, y'all. So I showed you that before. So these are some short answer questions. So you're going to take some time to get these done. If you need to stand up, get a little drink, take a little break, and come back to it, that's fine. So you're going to describe the difference between the theory of continental drift and plate tectonics. Sorry, let me get my mouse. Why was one believed and the other was not? So I'm already telling you that either continental drift or plate tectonics wasn't believed and the other one was. So you're going to tell me which one was believed and why. Be sure to include details that differentiate the two theories. So I want to know, how are they different? And you're going to answer in paragraph form. If you feel more comfortable with a Google Doc, you can attach that as well, or an audio file. So if you feel more comfortable explaining it verbally, that works for me. So this is a 10-point question, so you need to make it count. If you send me a video response, please note it in the answer. And then I have it written again right here. So you must explain both continental drift and plate tectonics, then describe what made one theory more believable than the other, meaning, was what Alfred Wegener missing? What was Alfred Wegener missing that made people say, nope, not buying that? And what did plate tectonics have that caused people to cheer, hip, hip, hooray, we believe your ways? So y'all, I'm kind of giving you little hints there. So take my hints and use them. Oh, I need to answer. ... There we go. Okay, number 18, time to take this quiz to the next level. So answer this two-part question below in short answer form and be sure to label your part A and part B. So you should have part A and then you should have a part B. So the outer layers of Earth are the crust and the mantle. So notice how, y'all, I'm giving you a hint to maybe some other questions before. So letter A, describe the difference between the density of the crust and the mantle. So density is mass divided by volume, how much matter is in a section. Not how heavy it is, but kind of how tightly packed. So what does the density look like of the crust versus the mantle? In letter B, describe the difference between the thickness of the crust and the thickness of the mantle. So you can even go back to that video that I showed y'all before and give me some data. Okay, number 19, which graph best represents the temperature inside of Earth? So A, B, C, or D. And explain why you picked that graph. Use specific evidence from the graph. You can zoom if needed, so you can zoom in or out. So, does A represent? And you have to look, where's temperature going up? Does B represent temperature of the crust, mantle, inner core, outer core? Does C and or does D? And I can't even explain the graphs to y'all. You got to kind of look at them. And in the answer spot, you're either going to type A, B, C, or D, and explain why you picked what you picked. Hey, y'all, number 20. Dennis believes that the Earth's crust is evenly thick everywhere. Priya thinks that Dennis is incorrect, but does not know any evidence to justify her claim. So which piece of evidence would help Priya win her case? She's saying that Dennis is incorrect. So Dennis thinks it's all the same thickness. Priya's saying no. What could help Priya win her case? Earth is somewhat flattened at the poles due to rotation. The continents are thick rock masses, unlike the ocean floor. Earth has a solid spherical inner core that is made mostly of iron, or Earth's plates are constantly moving at a very slow rate. So we're not saying that any of these are wrong. We're just saying which one is going to help Priya say that she doesn't think the crust is evenly thick everywhere. She thinks there's different thicknesses. Okay, 21, which of the following graphs best represents the relationship between depth and density of materials? So we're talking about as you go deeper in Earth's layers, is it getting more dense or less dense, and why? So this reminds me kind of that temperature question. So lithosphere is the crust, the core is the inside, and then you have to look at each graph and say what is happening to the density. So kind of have in your mind before you look at these graphs what you think the density is as you go deeper, and then look at the graphs and pick the one you want. Y'all, like I said, I'm always going to pick option 4 because I have to pick a answer. So I'm not saying that's the right or wrong answer. Okay, number 22, which of these statements best describes the lithosphere and the asthenosphere? So the lithosphere is rigid and immovable while the asthenosphere is hot and flowing. The asthenosphere is rigid and immovable while the lithosphere is hot and flowing. Both are hot inner layers of the earth and capable of bending and moving. Or both are hard and rigid layers of earth close to the surface. 23, which area is likely the oldest crust? So I'm looking at the mid-Atlantic ridge, and I'm noticing that magma is coming up through the center, and then it's spreading. So which one is going to be the oldest crust? At position 1, right here on the edge. Position 2, kind of towards the middle. Position 3, getting closer to that magma. Or position 4, where the magma is. Which one is the oldest crust? And like I said, y'all, I'm going to hit the last answer on all of them. Okay, 24, y'all almost getting there. So how could the law of superposition be applied correctly to the cross sections below? So y'all definitely go back and listen to my video. I talk about laundry on the floor and kind of what that reminds me of. So in the 1600s, Danish scientist Nicolaus Steno studied the relative positions of sedimentary rocks. He determined that sedimentary rocks typically form layers on top of layers. So if undisturbed, the bottom layer of the sedimentary rock is the oldest. Think of my laundry. Take off Monday's stuff, throw it down. Tuesdays go on top Wednesdays. Wednesday's stuff is the newest. My oldest stuff is Monday's that I threw there first. Today, this idea is known as the law of superposition. This law is one way to estimate the relative ages of sedimentary rock. The diagram below is a geological cross-section from Ohio. So this top part is glacial deposits. Then I have shale. Then I have sandstone. Then I have limestone. And then I have granite. So back to the question. I know this is a lot of reading, y'all. So how could this law be applied to this cross-section below? So the layers in the cross-section are all igneous, so this will not work. So what we're saying is that since these are all igneous rocks, you can't use superposition. B, the sedimentary layer in the cross-section is close to 5,200 years old. So the sedimentary layer, which one's the sedimentary layer? Did I identify that? The youngest sedimentary layer was deposited by glaciers. So we need to look where glaciers is, which one of these is glaciers, and how do we know if it's on the top, is it newer, is it older, and kind of go about that way. Or the youngest sedimentary layer can be found at the very bottom. So I need to see what this one is, which one of these, and they're saying that the youngest is found at the bottom. And y'all, my biggest hint is to reread this little paragraph about Nicolaus Steno. Okay, 25. Based on the scatter plot below, what is the best estimate of the mass of the rock sample taken from the area that has a volume of 300 milliliters? So a student collected many different samples of the same rock from a certain area. She measured the mass and volume of each sample and plotted the results on the scatter plot below. So notice on the y-axis, it's mass from 0 to 800 grams. And on the x-axis, it's volume from 0 to 800 milliliters. The question is, what is the mass of the rock taken from a volume of 300 milliliters? So you need to kind of look at the volume, find 300, and I can't even show you with my mouse, even though I want to, what you have to do to figure out the mass. Is the mass going to be 350? No unit. 450 grams, 550 grams, or 650 grams. And y'all, that's probably supposed to have a unit, so just keep that in mind. Okay, number 26, which statement best describes how the environment has changed over time? So we're going to look at this picture of this cross-section, and the diagram below shows the undisturbed layers of rock found in an area and some of the fossils found in each layer. which describes how the environment in the area most likely changed over time. So I see fish, then I see plants, and then I see some reptiles. So did it change from a desert to a lake? From a river valley to a forest? From an ocean to a desert? Or from a grassland to a coastal plain? And kind of look at each of those layers. Y'all, we did it. Yes, you did it. Double check your work. Make sure you submitted your all your different parts, and don't hit submit, y'all, till you go back and review. So you can always hit back, back, back. Like I said, y'all, kind of check through this quiz because I give you hints to some questions and other questions. So that's a great way to kind of use your resources. And also don't forget it's open notes, open journal, open Miss Brown videos, open Canvas. So you can use all of your resources. Hope that was helpful and reach out if you need any more help.